Good evening. My name is Cary Bran. I am here today to speak about connectivity and wearables. This is going to be a whirlwind talk for 15 whole minutes, and hopefully you'll come out of here with some knowledge about wireless technology and wearable tech. So a little bit about me. There we go. A little bit about me. So I'm the Vice President of Innovation and New Ventures at Plantronics. What that basically translates over to, in real speak, is that I get to lead R&D at Plantronics. So my team builds hardware and software prototypes, and we get to play around with sensor technology, wireless technology, and I think it's really the funnest job in the entire company. And speaking of the company, how many of you are familiar with Plantronics? That's awesome. Okay, so Plantronics builds headsets, and they have for 53 years now, I believe. We have been to the moon and back with our devices, so we've been building wearable tech for quite some time. We are experts in wireless technology as well as corded USB devices. So if it's about audio, it's about us. But what I'm going to be speaking about today, if my clicker goes, and it just started here, is wireless connectivity and wearable tech. I'm going to talk about NFC. I'm going to speak about Bluetooth, Bluetooth Smart, and Wi-Fi, and how that relates to wearable technology. That being said, there's a lot of other wireless technologies out there as well, and I'm not going to be covering those. So we're going to just, everything else we're going to skip. So when you leave here today, this is the one thing that hopefully you'll take with you, and I've got a rule of thumb. And it's going to be, maybe it's quite shocking, maybe it's not to all of you, but when you're building wireless devices, little small wireless devices, wearable technology, here's a simple equation for you to walk out of here with. So when you send bits over the air, it equals power. So bits equals power. So that's pretty easy to remember, right? Bits equals power, yes? Okay, good. So I'm going to build on this equation. So we're going to deconstruct it one level. So check this out. More bits is more power. So the more bits you push over the air, the more power you are going to consume. Does that make sense? All right, good, cool. So when you use more bits, and you're pushing more bits over the air, and you're going to use more power. So what does that mean? Well, that means more battery. So as you push more and more data over wireless, over the wireless connection, the battery size to power that transmission is going to grow. I'll give you an example. Similar to cars and fuel economy. I could have a Formula One car or a dragster, for example, and I could put 5 gallons of gas in that gas tank, and assume that gas is your battery size, right? I could go really fast, and I could transmit a lot of data very quickly, but I'm going to suck up a lot of gas when I do that. When you're transmitting data from your wireless devices, that is something you need to consider. Do I want the dragster? Or do I want more like the smart car with smarter fuel economy, right? So my data transmission is more intelligent as far as when it's going to transmit and more efficient as to when it transmits. And this is important with wearable tech, because, batteries have size. And when you have size, things get, when you need a bigger battery, things get bigger, right? And why is that important with wearable tech? Well, it's a couple things. Batteries require space, right? If you're building a form factor, there's no way that you can make battery shrink. Batteries are not following Moore's law as far as getting smaller and smaller and smaller. Batteries are they're laggards as far as size reduction. Similar to requiring space, batteries also add weight. And this is important because when you have weight, if you're putting a wearable device like on your head or on your ear or on your wrist or wherever, you have to consider what it's going to be like to wear that device all day long. So weight does matter. So as a designer of wearable tech, you may be asking yourself, well, why do I care about bits equals power? Well, it's pretty simple. Hopefully this will explain it. More power, okay? So if I come out and I'm designing a pocket watch and I'm really, I want this wearable device, it's going to have, it's going to be able to connect to the internet, and it's going to be able to tell the time, my pulse, and any number of other kitchen sink functions that you want in there. In the end, I may envision that I want this type of watch. But if I don't pay attention to that simple equation, I may end up like this, right? Size does matter. So you may have a device that flavor-flavs out. I mean, you get a big wearable when it comes to not being conscious of how much data that device is transmitting. So my advice is to, choose your bits wisely. Choose how you transmit wisely, and that goes down to protocol design. So when you're building your machine-to-machine language, you want to make sure that you're putting a lot of design into that. It's not just as simple as trying to fire hose the world with all the data that your device contains. You need to be designing your protocols with a conscience. And usually you can get by with using industry standards where they're available, and they're out there. All right, so now we're gonna move into story time. So I've got a story. It's more of a schoolhouse story here, but we're going to be talking about 4 radios and how well they could perform within the context of a wearable device. So these 4 radios, we have NFC. Familiar with NFC? Yes. Bluetooth, Bluetooth Smart, or Bluetooth Low Energy, and Wi-Fi. So we're going to look at them from the power side, but we're also going to look at them from a few other aspects. We're going to look at data throughput. So how much data can you actually push through that wireless radio? Scalability. And when we think of scalability, I don't think of being able to serve, it's not about the data that goes through it, but it's how many of these devices with these radios can you fit into a room. If this room were full and everybody had a wireless radio device, how well could they interact with each other? Would they cause collisions? That's the kind of scalability that I'm talking about here. The other piece is the third metric here is the platforms supported. So how well is it adopted in the mobile community on the desktop? This is going to be the report card for those 4 radios. So, and it's a very simple grading system. We're going to just go back to school here. We're going to use A, B, C, D, E, F. And I'm kind of a hard grader. Nobody gets straight A's, so let's just go through this. So NFC. NFC, if you look on the battery scale, it's actually the power miser of all of the wireless tech. NFC tags take 0 power. So if your wearable is just an NFC tag, you're not sucking any power off any battery. So you can have a very small wearable. The data throughput, it doesn't do so hot. You got about 424 kilobytes per second as far as your data throughput goes. So it's actually got pretty much the worst of the 4 radios that we're talking about here. From the scalability side, though, you can actually have NFC devices in mass. Everyone in here could have an NFC device, and they would not interfere with each other. And the reason for that is that NFC is very short-range radio. And it's really used, I think, as a good expression of user intent, because you have to tap with that device. So NFC, if you're building a wearable, it's great for that. If you have a user that needs to tap to authenticate or tap to get in line for tickets, it's a great technology for that. The platform supported, though there wasn't a lot of support in Windows to start with, or a lot of support in the mobile community. Android was probably the biggest one. It's starting to change. So the iPhone has it now, and Windows Phone, Windows, Mac, all of these folks are starting to support NFC or NFC dongles that can integrate with the operating system. Bluetooth Smart. So Bluetooth Smart or Bluetooth Low Energy, it also is very it's a power miser. So it's great. I think Bluetooth Low Energy is the wireless technology that will power a lot, and I mean a lot, of the wearables that we're going to see coming to market. It is really, really good for sensor data. All right, so you get a transmission rate of about 1 megabit per second. It's not so good in the sense of voice. So if you're going to put voice over it, send and receive audio, like you wanted to do a set of headphones, not the right technology to use. Scalability-wise, so Bluetooth and Bluetooth Smart operate in the same spectrum. So they only have so much of that spectrum that they can all occupy at the same time. If you're using Bluetooth Smart for sensor transmission, it's great. You'll probably run into very little, if any, collisions. How many of you have had like Wi-Fi and cordless phones and tried to get them to work together? And remember the outcome of that? You know, you'd get a phone call and your Wi-Fi would drop. Well, that's an example of collisions happening in the spectrum. The platform-supported Bluetooth Smart is pretty much getting a ubiquitous traction. Bluetooth, or Bluetooth Smart's older brother, Bluetooth Classic. It takes a little bit more battery, so it can take either 50% or 10 times as much battery, depending on how you are designing your protocol. The data throughput, though, is a lot higher than Bluetooth Smart. It's about 3 times higher. It's great for voice, audio. So if you want to do send and receive of audio, you want to listen to music, Bluetooth Classic is the way to go today. Scalability-wise, it's the same as Bluetooth Smart. If you bring a bunch of Bluetooth devices in mass, and they're all chatting because perhaps the protocols aren't designed so well, you could run into collisions. And they're more noticeable in audio because you can hear it. You can hear the drops, right? But it's ubiquitous and it's platform supported. So it's a great technology. It's really great for voice. If you try to shove video over Bluetooth, your performance is gonna suck. And lastly, Wi-Fi. So Wi-Fi loves power. It's fantastic. If you've had, how many of you charge your mobile phone every day? Your smartphone? Yeah. Okay. Well, Wi-Fi is probably one of the culprits behind that. Wi-Fi and any type of radio that requires a lot of power to send and receive is going to make your battery bigger. The data throughput, though, is awesome. If you want to do video, audio, sensor data, whatever, it's the biggest pipe of them all, and it scales very well. Wi-Fi is used throughout this building. We don't seem to be having problems with it. It's fantastic. Platform supported, again, it's starting to become more ubiquitous in mobile and obviously in the desktop platforms. But when I say mobile, I mean Wi-Fi direct. So being able to use it as kind of a peering kind of technology. Okay. So that's kind of the quick story there. So do you remember the equation? What's the equation? Oh, bits equals power. Right, so that's the one thing I want to leave you here with. So the more bits that you use, the more power it's going to require. The more power that requires, the bigger your battery. And the bigger your battery, the bigger your wearable device, right? So if I'm going to leave you with one thing besides that equation, it's to choose your bits wisely, okay? And if you want to continue this conversation, you can hit me up on Twitter. This is the hashtag for this talk, and that is all I got. Thank you.